Hello, I'm Bob Hodge, and welcome to Advanced Spindle Technologies Southeastern Service Facility. I'm glad you were able to stop by, and we'd like to show you around a little bit. This is our facility. We share it with Crotts & Saunders, our sister company, machine tool metrology equipment distributor. And this is our shop. You can see here we have the shipping and receiving where the spindles come in and go out and get packaged. Then we have over here our tear down and evaluation area with wash tanks and all that. The parts come in. When the spindle comes in, the parts of the spindle's disassembled to the component parts, and then those parts are evaluated. They're evaluated, they're measured, and they're assessed for acceptability. Then after the evaluations are done, there's a report that's generated. It goes to our customers. There's between 250 and 300 significant characteristics that impact the performance and longevity of a spindle. We evaluate and measure all those here and over here. Then after that is done, we put those in the report. We tell our customers what all those attributes are, and then it's up to them to make a decision to give us a purchase order. After the purchase order is received, then those parts would come out of storage over there in the racks, and then they would come in here. They would be prepped, they're cleaned, and then they would go into our clean room for assembly. This is our ISO 7 clean room. Come on in. This clean room filters down to 5 microns, so if you're worried about COVID, this is probably the safest place you would ever be. We have all of our tables out there and in here are stainless tops. The reason they're stainless is because they can be cleaned. Now within the clean room, we also have a class 2 flow bench here that actually filters down to below 3 microns. So essentially, and all the bearings are disassembled, or they're taken out of the package and they're greased here. They're put on the shaft here. So this is as clean as it gets, because the oil film in a bearing is about a 1/2 micron thick. So any hard particle that gets in there will potentially dent the raceways and start a premature failure of the bearing. The one thing that we haven't mentioned yet is our balancing capabilities. If you've looked at us on LinkedIn, you know we're pretty famous for balancing nickels and balls and pennies and everything on spindles. And the reason that we're able to do that is we balance down to G.4, which is the same as a gyroscope. And we do the final trim balance at runoff, but we balance, the key to it is balancing here the rotating components. All the rotating masses are balanced here. We have a shank HM2 that's good to 100 kilograms, and then we also have a shank HM1 that is for the very small high-speed shafts up to 10 pounds. And this is what allows us to balance down that closely. So when we make it to runoff and trim balance, we can actually get to that G.4 level. As far as our runoff stand, we have a duplicate of, we have the same one here in Winston-Salem and in Cuyahoga Falls. And we have it really divided into 2 halves. Here we typically will run off motorized spindles. Over here we will do belt-driven spindles, and we can do them both at the same time. Coming over here, we have an assortment of drives to run this motor. In some of the spindle motors, we have an assortment of lubricators, both air oil mist and air oil systems. We also have our chiller here that we utilize for motorized spindles to run the spindles under their own power. Everything is 100% runoff before it leaves our facility. We also have a Spindel 5000 Hertz drive to run just about any motor known to man. So after runoff, everything is documented. The vibration spectrums, everything is done and reported back to the customer. We also include the vibration spectrum, so if you're doing preventative maintenance, you can use that as your baseline, so you've got those spectrums already there. Then it's boxed up and it's shipped back to the customer. An example of where being a member of the HEH group and having a partner in the same building like Crotts and Saunders is here, where we're doing an evaluation of a bearing that's here. We actually have taken the bearing apart. Sometimes in a spindle it's pretty obvious as to why it failed, sometimes it's not. And in those cases where we actually disassemble the bearing and we do a bearing failure analysis. And what we've got here is, what are we on magnification wise? 14.5. We have the capability of going up to 130x, which we can basically start seeing microstructure of the steel at that point. But here you can see very clearly that this spindle was involved in a wreck, because these two dents here is where the impact on the spindle drove the ceramic balls into the race, making a dent, and then you can see where subsequently the balls rolled over them. So this was a wreck. The spindle ran for a little bit of time after that, and this is the cause of failure. And with all the equipment we have here as far as optical measuring, CMMs, all the machine tools, the reason this is a competitive advantage is a typical spindle repair shop could not dream of being able to afford all this equipment and all this expertise without it.